We're gonna have two kinds of logarithmic equations. One is gonna be something like this one on part one, where you end up with a logarithm, a single logarithm on each side of the equation. And in order to get that, we're gonna combine the logarithms on both sides. So here we have two logarithms. Because we have an addition, we're gonna combine them as a multiplication. So that's 3 times x. And we have another addition on the other side. So we're gonna combine them as 5 times x minus 2. When we get that, we could go beyond that, having logarithm base 2 of 3x, and we could actually multiply 5x and minus 10. If we have that, we could proceed to use the one-to-one property, just like on the exponential. We already have the same logarithm with the same base on both sides. So the difference maker is going to be the argument. So that's going to be 3x is equal to 5x minus 10, and we solve for x. That's going to get you a 10 equals 5x minus 3x. 10 is equal to 2x, and 10 over 2, that's 5. So x is equal to 5. If you were to substitute that on the original equation or the combined equation, you are going to end up with the same value on both sides of the equation. Otherwise, you would be incorrect. So if you do the logarithm base 2 of 3 times 5 equals the, let me do it up here. That's going to be this one, the logarithm base 2 of 3 times 5 is equal to the logarithm base 2 of 5 times 5 minus 10, or any version of the equation. So that's going to get you a 15 on both. So logarithm base 2 of 15 is equal to logarithm base 2 of 15. So that's one kind of exercise. The other one is when you have a logarithm on one side and a constant on the other side. So once again, you need to combine the logarithms. If you combine the logarithms, you're going to have logarithm base 10 of, and you're going to multiply both because you have an addition. So that will get you a multiplication. That means that we have to multiply those logarithms, those binomials. So that's going to get you x squared, so x times x, then x times minus 1 is minus x, 2 times x, and minus 2. And you could still simplify a bit. X squared plus x minus 2 is equal to 1. Because this is a base 10 logarithm, so this is a 10, we can rewrite it in exponential form. So that's 10 raised to the power of 1 is equal to x squared plus x minus 2. And now, in order to solve this equation, we need to have all terms on one side and set the equation equal to 0. That's going to get you 0 is equal to x squared plus x minus 2 minus 10. So that 0 is equal to x squared plus x minus 12. Now we need to factor this equation. We need to find or use the quadratic formula or any method of your choosing in order to find the solutions. So let's see if we can factor this out. We need two values that if we multiply them, we get a 12, and if we add them, we get a 1. What about 3. I have a 3 and a 4. And let's see, let's use -3 and +4. And that will get you a -12 and a +x. So the solutions would be x is equal to 3 and x is equal to -4. But we need to make sure that those solutions actually work. So let's try with the first one. Always test your answers. So you're going to have a logarithm. I'm going to write the base. And let's try with the 3. That's going to be 3 plus 2 plus logarithm base 10. And I use the original because the thing is that here we're going to have an evident problem if there is one. So that's 3 minus 1, and that has to be equal to 1. So you're going to have a logarithm base 10 of 5 and a logarithm base 10 of 2. So that looks like it's gonna work. It passes through the first filter, which is that it works for the every single logarithm. Now, if we combine those two, we're gonna have the logarithm base 10 of 5 times 2 is equal to 1, and logarithm base 10 of 10 equals 1. So that actually is true. Now let's try with the 4. Just remember that a logarithm cannot take negative values because it'll be undefined. So if we try with the -4, it looks like we're going to have a logarithm base 10 of -4 plus 2. And that's a red flag over there. Logarithm base 10 of -4 minus 1 is equal to 1. So you're going to end up with a logarithm base 10 of -2 plus a logarithm base 10 of -5. So if we have those values, it needs to work on this version of the equation, because if we combine them, we might lose sight of some of the problems. But this cannot even be combined because this is undefined plus another undefined. If we combine them, we would be missing the fact that we had an undefined value before, because if we combine them, we would have logarithm base 10 of 10, because -2 times -5 is 10, but we cannot combine something that is already undefined. So that's why the -4 won't be a possibility, and the only answer is 3. So always test your answers. Perhaps I should have the same thing on this one, but the thing is that we only had an x over here. So perhaps I should have used the 5 before the combination of the logarithms to have a better understanding whether the 5 was actually an answer or not. So try to substitute and play with the values from the original logarithm and not with the combined logarithms. That way you will be certain that the answers or the solutions that you're getting are actually the ones that will be defined.